and welcome back to the Raw Code Academy. My name is David Flanagan, although you may know me from across the internet as Raw Code. Today is a solo hands-on expedition as I explore a product called Spin from a company called Fermyon. Full disclosure, I have been doing some work for Fermyon recently, helping them produce content to show the world how cool WebAssembly could be. And we're going to run through a few of those examples that I've been working on today, as well as cover the basics about what Spin is, what Fermyon are trying to achieve, and of course, writing some code. Well, I'll maybe rely on Copilot to do most of the heavy lifting. So if you want to keep me company, feel free to say hello in the comments section. Let me know if you have any questions about Fermyon, Spin, or WebAssembly as we run through today's exercises. What I will do is, since I'm wearing a clustered Kubernetes t-shirt and the first kind of question came in during the holding screen, is tackle that. So Russell says that he is interested to hear what I think about Spin, as he's heard it is designed for Nomad rather than Kubernetes. So I don't have a link prepared now, but the first piece of content I did with Fermyon was an interview with the two co-founders. So that's Radu, the CTO, and Matt, the CEO. They're both responsible for, or at least they were contributors and maybe even creators. I can't remember the exact specifics. I think they were the creators and the maintainers and the contributors of a project called Crustlet, which was a fake kubelet to allow you to run WebAssembly workloads in Kubernetes. This is a project I've actually covered multiple times, maybe not on this channel directly. But there may have been an episode or a hack, but I have definitely played with it and talked about it when I were to Equinix and on my Discord channel once or twice. So running WebAssembly to me has always been interesting, and doing it in Kubernetes means that I can transfer a lot of that knowledge and experience that I already have. And of course, I can run workloads side by side. Like, there's no reason I can't run container-based workloads next to WebAssembly workloads, next to virtual machine workloads. And Kubernetes does give us a control plane that is extensible enough to allow us to do that. Looking back to what I said about the first piece of content I did at Fermyon was an interview with the two founders, is that one of the things that they shared was that they really pushed Crustlet, and it took a lot of effort to get a system that kind of worked. But what they found is they weren't really getting the characteristics that they expected from pushing an alternative runtime into Kubernetes that doesn't really conform to the CRI spec. The container resource interface spec is there to run containers. You can run other things, but Kubernetes and the kubelet and the CRI make a lot of assumptions about there always being a process within namespaces. And WebAssembly doesn't work that way. It's got its own sandbox, which is provided by Wasmtime or Node.js isolates, or whatever that runtime is going to be. So it doesn't even have any concept of POSIX. Now, while there's work with the WASI specification to kind of bring that to WebAssembly, at least server-side WebAssembly, these are things that are being added through something called the capability model, which allows you to extend the WebAssembly sandbox with new features by providing the ability to either gRPC or HTTP call out to alternative systems, which have, again, more constraints in place. So, what they said in there, and I will find the link to this interview. I'll stick it into the show notes. And if you just go to youtube.com and search for Fermyon, it's on their official channel. It was the most recent video, I believe. It's a really interesting interview, but I keep going off topic. But the thing they're really trying to drive home about why they went with Nomad rather than continuing, they've got a lot of experience in Kubernetes too. These are people that worked on the Azure cloud team pushing Kubernetes. They are responsible for Helm. They're responsible for Brigade. They're responsible for Crustlet. Kubernetes was their bread and butter. However, what they said was they pushed it as far as they could get it. And the startup times for containers are slow. If you need to run a new container, you're talking hundreds of milliseconds, potentially seconds, depending on whether network images there, IP address space, a whole bunch of other things. Things they don't really need to worry about with WebAssembly. And one of the things that they kind of affirmed in our interview was that Nomad is built to run different types of workloads. It runs containers, but it can also run the JVM. And actually, the JVM is much more compatible as a runtime to WebAssembly than it is to containers. So what they said in this, I'm just going to kind of reveal the whole interview now instead of making you go watch it. But what they shared there is that with Nomad, they have the ability to schedule new workloads and have almost sub millisecond initialization, bootstrap, and start of WebAssembly workloads on Nomad, something that just wasn't possible on Kubernetes. A strong proportion of our interview, Matt and Radu focus on WebAssembly is not a all-in situation. While we may have a future where entire companies and applications are built on WebAssembly, they really see them as complementary technologies. Like, you will always need containers. You will still need VMs. We still need VMs today, even though we have containers. So WebAssembly is there to enrich and augment those container-based and virtual machine-based workloads, or even bare metal workloads, if that's how you're operating. But give us a development experience that works locally and remotely just the same. And that's really what I want to show today as I play with Spin and explore it. So um, that was a bit of a divergence just to answer that first question, but I hope that context, that history, that flavor is useful to you. Russell, if you have any more questions, drop them straight into the chat. I see we have a question from Moz as well, so thank you for joining us, Moz, too. The first time I saw WebAssembly when I was trying to learn how to write Envoy filters using TinyGo. Does the Spin project use TinyGo or something else? Excuse me. Okay, so Spin allows you to write and develop microservices in almost any language, and we'll cover a few of the constraints there today. If you write your Spin application using their Go SDK, it does use TinyGo. Yes. It also supports Rust out of the box, and for that you're just using standard Rust with WASI target, and yeah, really Rust makes it really really easy. Hold on till I go block someone in the comments. Well, it's not quite made it onto live yet. I could just see it here. I don't have the ability to block from here. Oh, I think YouTube got them. All right, thank you, YouTube automation. So yeah, it uses TinyGo. Rust just uses Rust, and then any language that really compiles down to WebAssembly can be used. You won't have access to the same abstractions provided by Spin, but you can still do a lot of things. What I've really loved about Spin is that different modules can be written in different languages, and you can still just consume them, because once you've produced that artifact, that target, that small wasm.file, you just ship it to OCI or somewhere else, and it can be consumed. And I don't know if you're familiar, but Docker Desktop made a big announcement 2 weeks ago. That would be the start of November for anyone not watching this live, where they said that actually now you can use Docker pull commands to pull down WebAssembly binaries from OCI registries. And Docker Hub now supports OCI artifacts. So all these things are coming together. And then the special sauce from Docker is that actually you can run containers and WebAssembly side by side. So I missed this in an announcement, but someone pointed out to me just earlier in the week. But you can write a Docker compose file that runs a bunch of containers, as you always have. However, now one of those services could be a WASM binary, and it just runs side by side, does the thing, can communicate with the other services. And I think that's pretty special. And I'm really excited now. And I mean, I've always been excited about WebAssembly. If you're in my Discord server, you'll have seen many chats about WebAssembly and the things that we want to do with it, and the Trial project and other things. But really interesting being able to have a Docker Compose file that we know we're comfortable with, we've used before, we've been using for years, and just stick a WebAssembly service into there. And that's something I definitely will be exploring more on the channel in the coming days, weeks, or months. So Moz, yes, long way of saying TinyGo is what it uses there. Russell saying thank you for the answer, my pleasure. And then Russell is saying, I wonder if they will team up with Nova. Yeah, that project is really cool. Ori, I'm not sure. I've never said it out loud before. But definitely, we're going to see more innovation in this space with cohesive multi-runtime component things happening side by side. And I think that's really interesting. So let's get started. I didn't expect to do 10 to 15 minutes of questions, but really, really interesting ones. So thank you both for answering, asking. I had fun answering. And if anyone has anything else, drop it straight into the comments. I always love to kind of sit and talk. What I'm going to do now is share my screen. And I'm going to pull down their website as well while I'm at it. There we go. So this is the Fermyon website at fermyon.com. We're going to be taking a look at Spin today, which is their WebAssembly framework. It allows you to build WebAssembly applications. It provides all the cruft, the boilerplate, the glue. You just focus on that small little bit of code that makes up your domain logic. This is the promise that we got from Lambda and serverless functions and FAS, but I've never really seen that backed up with a strong developer experience like we're going to see with Spin today. And this developer experience about local and shipping to production is why I'm so interested in this space. So as we can see here, it is a framework for building event-driven microservice applications with WebAssembly components. Now, they stay event-driven, and that is very important because the Spin application, and this comes back to the reason of using Nomad, the Spin application is not just a service that runs perpetually and consistently. A Spin application responds to either a Redis queue, something going into a Redis queue, or an HTTP request. And again, looking back to the interview that I had, why Radu was so excited about this model is that they can spin up a WebAssembly module in under a millisecond, which means they provide the HTTP interface and they provide the Redis interface. And if you hit either of those, in under a millisecond, they can launch an entirely new WebAssembly instance of that application, pass in the request, spit out the response, shut it down, clean it up, garbage collect, and it's just done. This is really cool. With FAS built on top of containers, we've always had to struggle and fight with the cold start problem. And the cold start problem, again, comes back to it takes hundreds of milliseconds to start a container. So I either run these serverless functions on an endless loop and I scale them to what I need and I reuse connections whenever possible, again, violating this CGI model that we're trying to get to with serverless, where everything is handled by its own instance. But that's there to solve that cold start problem. And with WebAssembly, that goes away because the runtime is just that fast. Spin uses Wasmtime under the hood, which is a WebAssembly runtime written in Rust. So I've already installed Spin. The instructions are here. As far as the structure of a Spin application goes, we do have a .toml, and then we just have some Rust code. And look at this handler. How nice is this? Now, I'm a huge fan of Rust. I'm always talking about Rust. But this is just cool because there's a few things here that are very rusty. Excuse me, I've got a terrible cough today. First, we have this macro that surrounds our function. And let's just come back to that in a moment and kind of understand what Rust is doing there. But our function, again, has a very simple interface as well. It receives a request, it returns a result response. Don't worry about the result if you're not from the Rust ecosystem. It's just an OK tuple. But it just takes a request and spits out a response. You know, HTTP in, HTTP out. Then, ignoring the OK, which is just, again, our OK tuple, we just say, hey, we want to return an HTTP response. Rust provides a builder for this. We set the status to 200 and we return hello Fermyon as a string. We use into just to cast it into an actual string object instead of a Rust more primitive string object. Regardless, you can ignore it. And then the question mark is just to do some basic error handling in case any of that fails, which it really shouldn't in this case. So we're only focusing on what we need to relay to the user. This macro is what provides all the boilerplate. This is the procedural macro. It injects all the code into this function to make everything work and make sure that the request and the response are handled appropriately. Again, you don't need to do anything. When we have Rust and the ability to do this level of metaprogramming where we use macros to define boilerplate and keep it out of our domain logic applications, we get a very clean interface to build applications. And our microservices in a Spin environment are many of these. Every HTTP endpoint, potentially, that we want to handle has an HTTP component function. We can register the path for all of these functions in the spin.toml, and away we go. The manifest itself, or the spin.toml, just needs a Spin version, a name, and then we can set up the trigger. So the trigger at the moment can be HTTP and Redis. They are working on more support, and I'm pushing for some cron style scheduling so I can do some weird and cool stuff as well. And you can set a base if you're going to, if you want to compound multiple spin applications together, they all have a different base, but then they'll have subpaths within that. The architecture, the flexibility, whatever you need to do, you can really do. From there, we specify the component and the trigger, and away we go. Shouldn't talk so much when I have a cough. This is why I have guests, so that I can sit in silence for a little bit. All right, so that's kind of the basics. If we take a look at the language support, we've got the Rust one, which we kind of covered. The only thing you really need to do is Rust up add a target for Wasm32 WASI. This is all you need to compile any Rust program to Wasm and to WASI spec. It works really nice. You can see the exact same code from here, only this time we have the use statements to show that we are pulling in the spin SDK, which provides the HTTP component macro and the request and the response types that we are using within our application. If we pop over to Go, things are a little bit similar. Yep, here we go. We pull in the SDK in the Go way. We have an init function and a main function. So this is just setting up. Like this is this is our actual response. And then the main would have the boilerplate that you would need to handle it. I wonder if that could be done with Go Generate. I've not actually played with the Go SDK a whole lot. Because whenever I see Rust is available, I generally just go straight for Rust. The only time I don't go straight for Rust would be if there was a TypeScript SDK, and you can't do spin applications in TypeScript, but I don't think the SDK is there with the abstractions to make things simpler. As far as other languages, they do have a whole bunch of examples. Where's the link? You know what? I am just going to go GitHub Fermyon spin. There's a examples directory, I'm sure. There we go. And here we can see if we want to take a look at what. Oh no, that is just all Rust and things. I'm sure there's a grain example somewhere. Yeah, okay, yeah, and templates then. If you want to use grain, then we can take a look at the file. We just do print hello world, and that's enough. If we want to do something with Zig, which is another really cool language that's coming out in this kind of systems programming space, and we can take a look at the Zig example here. So all we're doing is we don't have the SDK here to mimic the response and request abstractions provided by Rust and by the Go SDKs. However, if we think about what a web server is actually doing, we're just parsing a string that comes in, which is an HTTP protocol string, which is mostly text-based unless it's not. Semantics I'm not getting into right now. And then we spit the text back out. So here we're just saying, here's the content header, here's the hello world, and let it handle the rest. So you can kind of do whatever you want as long as your language does support it. But it's probably best to stick to the SDKs. And I do think more SDKs will be added in due course. And that's just our Swift example. Nice. All right, we got another question from Russell. Okay, is it ideal to have lots of functions on one spin app rather than having lots of spin apps? No, I don't think so. That was just me yapping my mouth too much. I would probably just have a spin application for each endpoint because it's so easy to do. And in a mono repo environment where you can share a whole bunch of type descriptors, whatever language they happen to be, whether they're generated from protobus or JSON schema or whatever, I would just go down that approach. Spin applications are so lightweight, they're very easy to develop. I'd want to be able to test them in a very easy manner, and I would just have dozens of spin applications rather than lots of functions within a single spin application. It just means that each spin application is going to get its own different root prefix potentially, but yeah, that's fine. All right, so let's just see I kind of said at the start here, the developer experience is what's really pushing me to do more with spin. So let's take a look at that. We can run spin new. Let me make my font a bit bigger. We see all the templates from the repository. Now we've already looked at a few of these. So let's just say we're going to do. We actually did look. Oh, we never looked at C because why would you? So we can just do HTTP-C. You can do it with spin new and then just hit return, or you can do spin new and then the template name. here, I'll just say example C spin. We do some stuff, get a directory. We have our spin.toml. So this is just the spin version, sets up the offers and description, the HTTP trigger with the base, and then here is the component. So we're going to compile our C application to provide something called main.wasm. We set up the more trigger stuff. Waggy is it's a predecessor to the Fermyon platform, but Spin and the Fermyon platform can still run Waggy applications just fine because the CGI interface has not really changed that much. And then we describe the command used to build it. So again, any language that can compile to WebAssembly, you can set a component build command like so. And here we're using Zig to actually compile the C to WebAssembly, which is a cool wee trick. And we get the main.wasm and it works. But that's pretty boring. So I want to run through something that I have been playing with. So on the Fermyon documentation, one directory too high. So let's go up because there's more to this project than the spin app. On the Fermyon documentation, they run you through building a URL shortener. The URL shortener only accepts static routes. And what I mean by that is it only responds to requests with routes that are hard coded. So slash hello returns to here. And that's fine. But being very selfish, I have a use case where I need very static links, yes, but I also want to be able to use an API to programmatically create links. And I thought, well, why can't I do this with Spin? So that's what we're going to take a look at. So the first thing I did, because I like to over-engineer everything that I do, is I set up a Prisma project. In fact, I probably shouldn't do it that way. I should change the font size. I was actually coding for a change, so my settings are less live stream ready. I set up a Prisma because I love Prisma. Prisma allows me to describe my database tables, and it manages all the migrations for me, applies them to the remote clusters. This is set up to use a local Postgres right now. However, I did experiment with Prisma against CockroachDB, and it just worked. So we can use Prisma to speak to our database. We describe our models, and it manages the migrations for us. If I pop open the migrations folder, we have an SQL statement that says, hey, we're going to create this redirect table with these fields. And every time I change my prisma.schema, I can have it generate a new migration where it calculates what has changed and then always tries to kind of upscale and modify your remote database schema thingy, cluster, Postgres, Cockroach, whatever, to be the current version. What I've also been experimenting with, and I haven't got working yet, but I'm going to keep hacking on this, is Prisma comes with the concept of a generator. And here we're actually saying that we're going to just use the provider, which is a command. So we're going to use a cargo command called Prisma, which is actually an alias to run a main.rs here, which is a Prisma client CLI. So there is, oh, that's the generate code schema. So this generator is going to generate a Rust client to speak to our Postgres database or our CockroachDB cloud database. I've had some problems getting it to compile to the WASI spec or to a WASI target. And that's because the Rust client is using some features of Tokyo that aren't compatible yet with the WASI compilation target. I think there's other ways to go around this, but it's going to require a little bit more time and effort. But I'm going to keep working on it, and hopefully I can share some updates in the coming days and weeks. But we can generate a client. So if we pop open this prisma.rs, what we have here is a bespoke generated client in Rust to speak to my database with a kind of not like an active record model, but very similar. It gives you the ability to find things very quickly. It gives you the ability to do upserts and inserts and deletes. You just get a very good interface to working with your cluster. Here I can say, equals, or maybe order something, or is it in a vector? Or is it not in a vector? Is it less than? Exactly. This functional based approach to communicating or querying a database is very nice. So hopefully I get it working. However, I can run, go back to my CLI, Docker Compose up first, because I'm going to need a database. And this is a very standard Docker Compose file. There's no WebAssembly or anything in this at the moment. This is just, let's run Postgres. It's the most recent version, very secure password, and I expose the port locally. That's it. Excuse me. I also have Beekeeper, which is a GUI client to speak to databases. And what I'm going to do, as you can see, I already have one fake URL here, is I can just delete all of this. So I'll do it from here. Oh, maybe I can. Back. Docker compose down -v. This will delete everything, and then we'll spin it back up. This should clear any persistence, remove all the databases, and we should start from a clean slate, just because I actually don't know how to delete from Beekeeper. If I come back here, password. We now have no public and no redirect table. Perfect. So from here, I can run pmpx prisma migrate dev. This just means run my migrations against my dev environment, which is the local Postgres. It's executed, and if we jump back over to Beekeeper and we hit refresh, database is now in sync. Don't lie to me. All right, maybe the refresh button doesn't work. Let's try one more time. Hey, yeah, don't know why the refresh. Oh, there's another refresh. That refreshes the. All right. See, I don't use Beekeeper much, but it is a nice visual way to see the schema. So now we have a redirect table, which is empty. So let's just add one. And to do this, I do need an ISO 8601 timestamp because I haven't set up a default value on the created that and updated that schemas, although I really should. So I'm just using UTC time.now, where I'm going to say, okay, fake could be my live stream, which is going to redirect to twitter.com raw code. I can say here we want to do a 301, and I'm going to paste in my ISO 8601 string and hit apply. Now we have one entry as part of our dynamic URL shortener, in which case if the static routes do not match, which I'll show you in just a moment, go look up something in the Postgres database and do a dynamic route to there. So did I need to use Prisma here? No. Is it nice and cool? I mean, I think so. A couple more things about Prisma. There's lots of generators. So if you want to generate Rust types, GraphQL schemas, anything like that, there's probably a generator. You just add a little bit of code. This becomes your source of truth for what your models look like, and then everything else gets generated off the back of it. And I really want to be able to use this together with my spin application. Excuse me. Okay, so from here, we have our spin application. Here's my spin.toml. So this is my Raw Code Academy short links project, which hopefully I'll get working and deployed very soon on Fermyon Cloud. I'll show you that in a moment. And we can see here, I've got a little bit of boilerplate to point it to the target. Because I'm using cargo workspaces, this has to go up a directory before we go into target. And then we just specify the build command, which is just a cargo build target release. Nice and simple, nothing too strenuous about putting this together. And if you use one of their templates, it does it all for you. You don't need to worry about it. From here, we have our lib.rs. So much like we've seen in the documentation, we're going to pull in the Spin SDK, which provides request, response, and HTTP component. They also provide some other components, one of them being the ability to speak to Redis, and the other one being the ability to speak to Postgres. So we're pulling in this PG library so that we can send queries to Postgres. We have our procedural macro that does all the glue for us with this application. We have our function to use as our entry point. And I've got some really crappy debugging in here, which is the print line path, which just tells me the path for each request that comes into the system. Next, we do a match. So I'm saying, okay, let's just look at what the path is. And these two here are my static routes. I can say, yeah, why not Copilot? Let's do GitHub. Although I'm not going to trust your thing here. And we just do a default redirect for that too. Now, what is default redirect? Well, let's copy it and do redirect GitHub. And instead of going to the Raw Code Academy website, we're going to go to github.com, Raw Code Academy. And then we'll change our static rules to be redirect GitHub. Now, of course, this is probably not idiomatic Rust. Would I create a redirect GitHub? No, I'd probably just have a redirect static function that takes a string where I pass in the URL, probably a bit cleaner, but just for the sake of moving on with today's demo, we're not going to bother about that. But what I wanted you to take away is that we can add to this match statement all the static paths that we want, any URLs that we always want to be shortened in a particular way, regardless of what's in the dynamic configuration, which requires a database lookup. We want to respond really fast, and we put them here. But of course, we don't. Of course, we likely want dynamic lookups too. So our last part of this match statement says, okay, whatever the other value is, let's just call it path. And when we get a path, we're going to do some more horrible debugging, which is the exact same debug as above. So I'm actually just going to remove that. I'm going to trim the slash off of it to make the match a little bit cleaner. You know, we don't in our database want this live to be slash live. We just want it to be live. So we'll just trim it off. So if the string starts with a slash, disappear. Then we have a redirect lookup command. So this is the function that goes and speaks to Postgres. We pass in the trimmed path, and whatever it returns is what we finish with in our function. The fact that there's no colon here or semicolon just means that this is a return value to the match, and because the match doesn't have a semicolon, this is just Rust logic here. This is the last expression within the function, and it will be returned as our response. So let's pop down to redirect lookup. Excuse me. Now, we have a hard-coded string here. This is very crappy. I get it. Currently, there's not a great way to deploy secrets to Fermyon Cloud. However, they are working on it. So just because that's not really, there's no primitives yet. There's some things in config I don't want to dive into just now. I'm going to do more on that next week. But let's just get this example working. Let's hard code it and it'll be fine. That was my logic. I hope that makes sense. And I'm going to skip over it for the rest of the session. Then we configure our SQL statement. So how do we find a short link within our database? Well, we select long. The only value we actually care about is long. And I probably should, let's fix my code and pull back the status code since we have that in Beekeeper. Redirect code, sorry. Redirect code. From the redirect table where short, so that is this key here, equals, we're using parameterized SQL statements here so that we're not vulnerable to SQL or SQL injection attacks. And then we use the Postgres helper provided by the Spin SDK to query at the address, which we define above, the statement, which is our SQL, and then any parameters. Now, because we have a $1, we need exactly one parameter here. So we just use the Spin SDK to say this is a string type, and then we pass in the path. If there's an error, we map over it and return that there was an error executing the query, although we're assuming that it's going to just work. This is a very simple query. Don't expect anything to go wrong. We have one edge case, or not really an edge case. We have one case where what if we don't have a URL in the database for that? So for that, we return a HTTP response builder status code 404. Hopefully self-explanatory. Now, if we get past that point, we know that we have at least one response. Now, in our schema, we actually do specify that our short is an ID. This will make it unique. I wonder if we can see that in Beekeeper. Use structure, primary key. Oh, created that does have a default value. Okay, it's just updated that it doesn't. And if we go to indexes, yep, we have our unique primary key here. So we actually can't, hopefully, be in a position where we can have two shortcodes that match. However, I just baked it into the code. So we always pull out 0 base because we have that guarantee from the database that we're never going to have a 1. We don't need to do anything smart. We're just going to take the first one. So we do row set rows get 1, add 0, unwrap it, get the index again to get the first column, which is our link. We can actually get all of this back and use the redirect code. If I'm feeling brave and we have enough time after we do the DX workflow stuff, maybe we'll do that. If this is a string, we return it, and if so, we do a redirect to the location. And then this is just a little bit of boilerplate that is needed for working with the PG Spin SDK. I grabbed that straight from the docs. I'm just going to trust it does what it does. Trust that it does what it does. It's just guaranteeing that, or trying to guarantee that if we get a column back and we say that we want a string, that it is going to be a string and not some other type. Now, it's not a lot of code, 70 lines of code. Most of that could be cleaned up. I don't need redirect GitHub for a start, which takes away nearly 10 lines of code. And our lookup could be cleaned up as well, but we're doing, multiple lines to kind of make it fluent and easy to follow. So let's jump over to the terminal. We generated our migration. We run our database. Now we can run spin build. Oh, in the spin directory. This will compile our Rust application, and we will get our Wasm target. So if I do target, release, build, oh no, where's the, in here somewhere, oh, Wasm, release, and we have our shortlinks.wasm file here. So we've successfully taken our Rust code, compiled it down to WebAssembly, and now we can run spin up. Now, it's very fast. In fact, if I run spin up again, almost instantaneous. We could probably use Hyperfine if this exited, which it doesn't. But that would tell us it started insanely fast. We get a web server on localhost 3000, and it tells us the available routes. So if we were to configure spin to do multiple endpoints, which you can, they would be listed here. But what I could do here is say curl on just a slash. And I'll do that one more time without the slash. They both match to the same. We get a 301 to the Rockwood Academy and 301 to the Rockwood Academy. Let's see if we run Hyperfine on this. And I'll need to do... Yeah, we're getting our response time over HTTP, remember, even though it's localhost, so it's, we got no ping latency or anything like that. But this application is responding with a deviation of about 2 milliseconds and 8 milliseconds. So we're seeing responses anywhere from 5.6 milliseconds. Well, I actually went up to 19, but the mean time is within 2 milliseconds of 8.4. So in roughly 8 milliseconds, we're getting a response over 241 runs. This is on a local machine, and it's over a URL that isn't hitting the database and a few other bits and pieces. But still kind of cool and very, very fast. If we do a curl and we do blah, 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 we're going to get an error. Oh, it's now complaining about my redirect code. And that's because I was feeling too brave. Let me remove it. And we just do a spin build, and I'm just going to run a spin up. Let's try that one more time. There we go. We get our 404. So what if we run this under Hyperfine? Remember, this one does have a database lookup because it's not doing a static match, and then it does have to speak to Postgres to see if there is any match. So it's still failing and returning no rows. And we can see we're getting a mean time of about 25 milliseconds. It's actually a bit slower than I was expecting, but still insanely fast for what is actually happening here. So HTTP request, speak to the database, spit out a response. Not too shabby. And this is that Postgres running in a local container on my machine, not optimized or tuned or anything like that. So these numbers are really, really cool. And again, pushing why I am excited in WebAssembly. So let's make this work with our dynamic link, which was live. And we'll see here that we get a 301 going to twitter.com/rawcode. So I think this is pretty cool, pretty neat. Now, for the eagle-eyed amongst you, there's one gotcha that I kind of had to work out, and by work out, I mean I just had to run like a spin up -- help. But my log output that we have on the URL match here is nowhere to be seen. So the way that we fix that is to run a follow all on the spin up command. And now when we run our curl, we see our path output here. So if you are working on your spin application locally, which I assume you will be, we can run follow all to get the logs to our local terminal. And this just makes your debugging a lot easier. And you can see even with the database, we're still getting that 25 millisecond response time. So what's that dev workflow look like, just to confirm? Well, we modify our code. We run spin build, spin up, and we run curl to GitHub 2. And we got our 240 odd responses. 266 this time. There we go. Static links in 8 milliseconds. That is pretty sweet. So that's the demo. I like the dev experience. I like the simplicity of the functions, relying on Rust's procedural macros to mean that I only write the code that I care about. I like that they provide libraries for speaking to Postgres and Redis. I want to do more with that. I'm really eager for them to do some sort of secrets management, because really what I want to do is after I've done my spin build and spin up, is we have access to a spin deploy command. And we just run this and we get a link back with a production URL for hitting all of our traffic. So here I have a Fermyon.app, and I'm going to run Hyperfine again, but inject my new URL, which is delivered over TLS for free. Oh, those times don't look as good. However, Fermyon Cloud is hosted in US East 1, and I am in Europe, so the latency at minimum is probably going to be about 300 milliseconds. But we had 10 requests to the remote server that responded. And just to show this, oh, I copied that by mistake. Just to show you the headers here on the response. There's why it's so slow. Let's try IPv6 first. So let's do that again with -4. Yeah, much faster. And we get a redirect to GitHub Raw Code Academy. So lots of really cool things here. Spin build, edit code, spin build, spin up for local development, spin deploy, throw it to Fermyon Cloud for free, get TLS, get custom domain names, all this other cool stuff. I'm going to be doing a lot more with this entire platform because I really want to push this URL shortener to do my own bidding rather than relying on services like Bitly. And another really cool idea I've got is I want to build my own analytics engine, like Google Analytics, but using just WebAssembly and request, because I reckon we could do some pretty neat stuff in the browser and on the server to get a really cohesive analytic experience. And I'm going to push that as far as I can go. I'm going to jump back to Monologue Face, check for any questions, but I hope you like what you've seen, and hopefully your interest is piqued and you can check out Spin and WebAssembly. We got a question from Moz. Does Rust follow TypeScript syntax? They have some similarities for sure. They're both modern languages that I've learned a lot. They provide strict typing. They have functional constructs, the ability to map, reduce, etc. They have error handling. So there's a lot of things that are very similar. But I'd say the Rust syntax is more esoteric. TypeScript is a lot more familiar to people coming from C derivative languages and JavaScript, it'll feel very, yeah, or even Java, it will feel fluent and easy to understand. TypeScript with procedural macros and the unwrapping of everything and lifetimes takes a little bit more effort. But if you see similarities with TypeScript, that's good. Don't let the scary stuff scare you away. So Russell said, so was it created a new connection for each request? I got on a phone call, so missed some of the video and still responding in only 25 milliseconds. Yeah, the spin runtime only launches the WASM binary when a request comes in that matches the endpoint, the route that you have it got configured to. So everything that you're seeing is the spin runtime, the Fermyon platform, which is also open source, by the way. You can go to github.com/Fermyon. You'll find a platform open source repository. You can run it yourself on an EC2 instance, on Equinix Metal, on GCP, whatever you want. Pass it some WASM files, and away it goes. So yeah, you're getting a unique instance of that WebAssembly application for every request or every Redis message within the cluster. Cool. All right. It looks like there are no more questions. Thank you for joining me today. As I said, I'll be doing a lot more with WebAssembly, and make sure you tune in for the next episode. Thank you again. Have a wonderful evening. Adios.
Thank you for watching Warcode